Hi everyone, I'm Courtney Bear, and this study is looking at Trinity and Wykeham Glaciers, which are two of the largest and fastest tidewater glaciers in the Prince of Wales ice field. The purpose of this study was to determine the use of the GIV software for creating velocity maps. It was also to determine Trinity and Wykeham Glaciers' seasonal velocity trends from 2016 to 2021 and what the drivers of the variability that were observed are. So the methods used, we used Sentinel-1 SAR-based velocity maps. Sentinel-2 optical imagery was input into the GIV software to create velocity maps, as well as looking at climate reanalysis and sea ice data. So one of the first things done was the validation of the GIV velocity maps. Generally, these maps aligned well with the SAR-based maps, so a combined data set of both the SAR-based and GIV maps were used. Moving on to the velocity trends of Trinity and Wykeham Glaciers. Both glaciers show the fastest flow at their terminus. Figure 2 shows the monthly velocities of Trinity Glacier from 2016 to 2021, with Figure 3 showing the same thing for Wykeham Glacier. Some of the biggest findings of this study were two distinct types of flow that occur. The first flow we refer to as fast flow, and this occurs when there are minimal velocity changes from one month to the next. The second type of flow we call seasonal flow, and this showed large drops in the velocity in the summer months. So this can be seen in figure 4. Figure 4b and figure 4d show the velocity percent change from month to month. When there's a large negative velocity percent change, this is caused likely by meltwater exiting from under the glacier in efficient drainage channels. When there's minimal velocity percent change, it's assumed that this is caused by basal sliding continuing into the summer with inefficient drainage channels. Figure 4e shows sea ice, which was used as a proxy for understanding the melt that occurred. As seen in figure 4e, when there was less sea ice and thus more melt, this occurred in the years with seasonal flow. When looking at climate, figure 6 shows that the above average temperature years typically corresponded to the years with seasonal flow, while below average temperature years corresponded to the years with fast flow. So in general, this shows that above average temperatures leads to more melt, which leads to efficient drainage networks and summer slowdowns that we observe in the seasonal flow. So in conclusion, it was determined that the GIV velocity maps can be used for Trinity and Wykeham glaciers if SAR-based velocity maps are not available. And two types of flow, seasonal and fast flow, appear to be driven by temperature.